Okay, we will try to explain opendir and readdir and closedir. I just will take 3 of them and explain the 3 of them, and just will write one code for both, like for the 3 of them. Okay, so just we can take opendir. Is screen is good or okay? Okay, we have the first function is called opendir, and this function basically you give it the path or the name of the dir you want to open, and it will open this dir for you. And for, like, we know for using this function we have to include some libraries, and this is 2 libraries to include. And let's go to the syntax of the library, of the function. The first thing is the variable. This variable, you just declare this variable to save the result. Okay, the result of the function inside this variable, and this variable from type dir, because you are treating with dir directory. So basically we need a point. This is a pointer variable to store the result from the function. And so we said before, any function you want to use, it has some condition or some requirements to use it. Requirement of this function just to tell it, the function, what is the path for or the name of the dir you want to open. So you will have to declare a pointer variable or to define a pointer variable to hold the path or the name of the directory you want to open. Okay, so now we can look at description. Return, okay, this is the returned value. We just can description opendir function open a directory stream corresponding to the directory name, and return is a pointer to the directory stream. So the stream, okay, and on error it returned null. So we can just check return value. On success, it returned a pointer to directory stream, and on error it returned null. So basically, again, our function is so easy. If you want to open a directory, you just call the function and give it one parameter, and this parameter is the name of the directory, and to store the results returned from the function, you have to define or to declare a pointer variable, and this pointer variable from type dir. Okay, so our question always like, what do we need to use this function? The first thing is like a pointer variable from type dir to store the result from the function. And second thing is to declare a pointer or to have a pointer variable, and this pointer variable for holding the name of the directory. Okay, and just that. Okay, and we set the return value either the pointer to dir or null. Okay, and if we just open a directory, force that because we want to do something inside this directory, so we have another function called readdir, and yes, that's it. Okay, so readdir function. Okay, readdir. It's read what inside the directory. It reads different information inside the directory. and we have to include this library. And let's take this structure or the syntax. Okay, let's okay. It's the first. Let's take this. Inside the directory, you will find different things. Like you can find files or directories, and every file and every directory have some information. You maybe want to know this about this information. So because of that, like our variable which will store the result from readdir will be struct, like a structure. We know that structure is something like array, but array can just hold one type of data, like all type should be like integer or should be float or should be char, just one type of data. But the structure can hold different type of data. So you can, if you declare in structure, you can put integer and the char and the float or double or any type of data. Because of that, if we want to use readdir, that means we will read different type of data. So if we will read different type of data, we need a variable, and this variable can hold different type of data. Because of that, our variable here will be struct, will be a structure. So the type of our variable will be structure, and we will have a pointer variable to like any name we want. And but here it's like readdir. So readdir, it's a variable to store the result from the function, and the result, okay, and where the result will be different type of data. So because of that, we need a structure to hold a different type of data. So the first thing we have here is structure, and the structure will hold different type of data returned from readdir. And what is the parameter the readdir or our function needs? This parameter, it's the returned value from open. So we here we opened our directory and we save the result or the returned value inside this variable. So just the parameter of read, it is this variable. So the first or the only parameter, it doesn't take anything. Okay, parameter, okay, we can say it's the result from the opendir function. Okay, so if okay, let's go to the returned value at first. Okay, maybe you just look and add this. Okay, here they just give you the information. You maybe can find it inside when you read the dir. Like okay, wait. When we open dir and we open successfully, we said that we will save our result inside structure. Okay, so it here like saying for you what is the result you can found inside the structure. And the first thing we have here, it's in node, and this in node, like you can say, it's ID for files. So if you inside your directory you have many files, and each file has its ID, so you can access the ID of the files through this this in node. Okay, and offset here, number, what is the meaning of the offset is like a position. When you when you open a directory, of course you have a position on one file, or the first file or the second file or third file. So offset, it is the position where you open your directory. And the third information we can get from structure here, or return it from open from read function, it is the length size, well, like a size of directory. So if the directory like have many files and many other directories, so what is the size of your directory, of your main directory, or like length, or how many files and directory inside your directory. And the d type, like it's return for you the type of files or directory inside your directory. So like for example, wait, um, make, okay, make dir, dir 1, dir 2, dir 3, and touch file 1, file 2, file 3. So now inside my directory, which is called example, I have dir 3, dir 2, dir 1, and file 1, file 2, and file 3. Okay, so here d type returns that I have type of, I have file, and here file and another file. So I have in my directory files, and I have in my directory also, sorry, like directories or different other directories. So d type here give you like in what type of like thing, maybe you can say things inside your directory. If you have file, or you have directories, or you have like images, anything else. Okay, and the d name, it returns the name of files or directories inside your directory. So we said in node, it returns the ID of files and the offset where mainly you are stand in your directory. So when you open your directory, you like point to this directory, or you point to this file, or where are you point, or where are you stand. uh, Length, it's the length of your directory or size of bytes. And the type, what type of data inside your directory, is this file or it's directories, or it's what you have inside your directory. And the name, it's just returning the name of data or files or directories inside your directory. Okay, and here, okay, inside LD type, yes, LD type has many different types, like ways to, okay, okay, this is D type. Here, like you have here, if dt link, you are checking on symbolic link if you have inside your directory symbolic link, or dt dir if you have inside your directory another directories, if you have character devices, or if you have just regular file, like file we just created, this is regular file and this is directories. um, or you have unknown, that's a file you can't determine which type, what is the type of this of these files. Okay, so just the most common of this, we just always like search about another directories or regular files, maybe symbolic link too. And we should look here on the returned value. On success, readdir returns a pointer to dir end structure. Okay, and on failure, okay, at the end, the null is returned on error, or indicated the end of the file. Okay, okay. So on here we can say return value on success. It will return. We said we return a structure, and this structure has all information about data inside the directory. On error, it will return null. Okay, okay, that's it. So if we state what we need to use this function, again we want to open A pointer, not okay, it is structure, struct variable to store the different type of data inside the dir, and we have to give it a parameter, but we don't have to open any or start any variable for this parameter. It's just a parameter from opendir. So like give it param, return it from opendir, okay, dir function. Okay, then close dir. It just like it doesn't need anything. It just when you call it and give it a parameter, and this parameter is the return value from open function too. So the param it needs is the result from open dir function. Okay, so maybe we can just go through steps, and we say include at the first include libraries. Second thing, that the first function we will use, it's opendir. So let's go back to opendir and see what it needs. It needs a dir or pointer variable from type dir, and a variable for or pointer variable for the name of the directory. So pointer variable from type dir, 3 pointer variable to hold the name of the directory. This is open function. Read function, we said that it needs structure. We can say int and read dir, and the close doesn't need anything. So our next step, we said we want to open, so we have to call open dir function and store the result inside the variable, and we have to check for error at first. And the next step is to read what inside the directory. So we have to call read function. Then we check for error. If we want to print like the name of the files or directories, and then we have to call closedir function just to close it and just end the program. So maybe we can just go and try to write the code. Okay, opendir.c. We have at the first to include our libraries. Okay, so here it's dir, and I'm not sure this close. Okay, maybe we just can see close. Okay, type and dir int and types, I think both of them we have it. Okay, so we will start our main function, and then we start to declare our variables. And the first thing, it's dir. Okay, dir asterisk to like dir, and the second thing is for path name, so char pointer path equal to I will just open the current directory. Okay, and then we have to have struct entry, and I will call it readdir. Okay, and is there anything else here? Okay, and pointer to the name and struct, and I think nothing else. So now we just have to like start to call our function, and our function is open, so we want to call it and like save the returned value inside our variable which we declare for open function, which is dir. So dir will be equal open dir, and we'll give it just the path name to our directory. Okay, and then we will check for error. So if dir equal to null, we just will say print error, can't open the dir. And else, that's mean, or not else, like if not this case, that's mean we open the dir successfully. So we'll go to throw a loop. Why I'm doing a loop? Because inside the directory you have a structure, or your variable is structure. Structure is like an array. So if you have multiple data, you just loop on it to just go through every data. So because of that, I have a loop, and I just will like check the condition inside the loop. So I will say readdir. Readdir, it is a variable which I will like, when I call the readdir function, I will save this information inside this variable. Okay, so readdir, and I will call the function, and I will give it the returned value from open function, which is the dir, and I will say if they not equal to null. That's meaning that's mean like the returned value from readdir not equal to null. What is the mean of not equal to null? That means it's not error, and I keep looping over the old structure. Okay, so here I will check for some type of data. So I will check for type regular file. I will check if there is any regular file inside my directory, and then I will check for if there is any directories inside my directory. And for everything, like for checking in about the files, if there is files, I will print their name. If there is no files, it's okay. And I will check for directories. If there is any directory, I will check their name too. So I will have my if condition, if readdir, and readdir, it's the structure which have the whole information inside the directory, and I want to access on the type or d type, which mean I want to access about on the, like we said here. Okay, not here. We have here inside the structure, we have different type of data. One of these data is d type, and d type holds the type of data inside your directories. Okay, so I will go inside this type of data, and I will say to it if this type of data have regular file. That's mean like if we go back here, if we check our data, our type of data, we will find here one of them called dtype reg. That means this is a regular file, which means any file you created is called a regular file. So here I'm checking if there is any regular file inside my directory, and in my checking I will say if there is any regular file inside my directory, just print its name. So I will say file s/n, okay, and then read dir slash d type, no, not type, it's name, d name. Okay, so here I'm saying inside the structure, or inside my structure which have the whole information, I just picked one type of information I need to know, which is the type. If the type is equal dtreg, which mean regular files, if you found any regular files inside my directory, just print the name of this file. Okay, I think okay, and then I will close this and I will say else. If this means I just try to check another condition. Okay, what is the condition I need to check here? I need to check if inside my directories there are another directories, yeah, like there are another folders. And if there are another folders inside my directory, I want just to print their name too. So I start my structure or the name of my structure, and then I will access to my structure, and I will access to type specific data. And this type I'm saying if it equal to dt dir, which means there is any directory inside my directory, I just will print if dir /n, and I will say read dir, and I want to access in the name of the directory. Okay, and I think that's all inside the while loop. So and then I just will, yes. Okay, yes, 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 it's S, sorry, yes, printing error. Thank you. Okay, and here I just will say I will call my close function, so I just will say close dir, and then give it the name dir, and I will say if it equal to -1, it's a -1, right? Yes. Like print error, can't close the dir, and just close it like this and return 0, semicolon, of course. Maybe we can here just return 1 2. Okay, here I'm just like call the function and it checked for error at the same time. Like I call the function and check the error instead of like opening any another variable and check in new line. Okay, so I think that's all for this. Let's try to combine cc opendir. Okay, cc not bb. Okay, type. Uh, I think it's just okay. So what's the error? Okay, dereferencing pointer to incomplete type struct entry. Okay. Wait. Readdir, structure entry, and readdir, and dir int readdir. Sorry. Maybe this is okay. 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 Here it says like dir. It's like I have here. This is the first. This is my dir directory, and this is directory before. And I have file here and directory dir1 and dir2 and dir3, which I created before, and like dir files, file1 and file2 and file3, and open dir.c and open dir. So it's like a check for directories and file and print its name. Maybe we can write steps here. Okay, we can say here okay, call opendir function to open the directory and store the result. And here we checked for error, and here if there is no errors, loop over the structure to check for information, and here checking if there are files. Okay, checking for files or there are files, and here if there are files, just print the name, and here checking for directories, and here if there are dirs, just print their names too, and here closing okay, the dir and check for errors. I think someone raised his hand. You can open your mic and speak if there is someone. Anyone? Oh, okay. To use comments. What? I didn't get him. Did you get him? If you are saying yes, you if anyone understand, he can explain. No, I'm here just putting comments to organize the steps with you, but you don't have no. But yes, okay, I can say just if you are building a complex application, or I'm not talking about our tasks now, but I'm talking in the future when you inshallah get a job. When you have a complicated project, sometimes you need to yes, write comments. Why? Because maybe after sometimes you create this application and you forget about it, but it is in your GitHub, and maybe you need to go back to this application again. So when you go back, you will forget everything. So when you see comments, you will start memorize what you did here and why you declare this and why use this function and why you every step will be clear for you. So I'm not talking about now or our tasks, I'm talking about in future. Yes, you need to put some comments, but not random one. Don't put comments for things is easy. Just put comments on complicated steps or tasks or application for you when you get back, or for anyone. Maybe another one will go through this code and try to handle some issue or try to edit in it or try to update it to put another feature. So you should have some comments explain the complicated part of the code to make him understand what have you done, not to make another errors in code or make everything messy after you just wrote or build your code. Okay, so sometimes yes, comments are important in big projects and in complicated code or steps. That's all. uh, and anything? Okay. Emmanuel, you were saying something? Okay. Uh, okay. Uh, mm, yes. Okay, I got you. Look, I didn't try it before, to be honest. But maybe you can try after session to like play with this code and try if we get this result or not. But I'm not sure because like we try to access the information about files and directories inside this directory. But to open it, I'm not sure. I didn't try it before, to be honest. So maybe you can try it. Okay, welcome. Okay. So I think the next thing is the strtok function. That's it here. Okay. Uh, String tokenization or strtok function. Basically, it extracts tokens from string. What is the meaning of tokens and yeah, like what is extract tokens from string? You can say it breaks down the string into small pieces, and here, like in programming, tokens is equal to small pieces, equal small pieces. So our like if we say like hello world, if we say just to recall our function about on this string, it will like break it down into small pieces, which mean like hello in a line and word in another line. So mainly our function break down your line into small pieces and give you these pieces in a string, array of string. So um, maybe you just can ask about why we need this function, or why we need to break down our commands or our string into small pieces. Uh, yes. Hmm? Yes, yes. Don't worry. Okay. So if we ask why we need to break down our line into small pieces, basically like I'm as a user, if in simple shell now and I'm a user and I have a prompt inside me, like if we say this is a prompt, I will write ls dash l a or dash l and a and slash for example temp. If we don't, if we didn't break down this line into small pieces and I have ls in a place or in a line and l in a line and a in a line and slash temp in a line, if I didn't do that and execute every command alone, I will have this line like that, and our function will just execute ls. So if our flag la or slash l, sorry, slash l, or our flag a or our another directory slash temp will not be executed. So the result will be just on ls, and all of that will be ignored. So mainly we need string tokenization or string token function to break down our line of command into small pieces to y to execute each one individually. So I can execute ls and slash dash l and a and slash temp. So because of that, we need a function break down our command into small pieces to execute each piece individually, because each piece like do a specific job or a specific function, and we need all of these functions to be performed. Okay, so that's why we need this function, and we said that it's break down our string into small pieces or into tokens. So small pieces in programming called tokens. Okay, and here okay, if we need to use it, we have to include this library, and let's break down its syntax. Okay, the first thing is char pointer string took, and that's mean we have a pointer variable to hold the result from the function. So it's a pointer variable to hold the result from the function. So what is the result back from this function? Let's say my string is hello world. Let's try to make it more bigger. Okay, hello world from C. Okay, so let's come here. If I now use my function to break down this line into small pieces, so mainly like I just want to make you imagine the shape of output. If we say output, okay, it's equal token. This is a variable which will save the output. So output will be like hello world from C, and it should end with null, because why? At first, it's return a string, and this string will have your tokens or your pieces, which we cut it down or like break it down. Okay, and if we know and remember that any string in C should end with null or like null, which like that. Why? Because if you when you include this symbol at the end of the string or array of string, you are basically say to the program, this is the end of this array, so you should like close this array now. So this symbol like saying to the program, you should close this is array of string now. Okay, so our token at the end should be looks like that. Our returned value from function should be look like that. Okay, the returned from the function. Okay, and here we can say null. Okay, to the program, that is the end of the string or array of string. Okay, so our first parameter is the pointer to variable, which is array of string, will hold the returned value or the result from my function. Okay, and this function take two parameters. The first one is char string. Char string, which mean like pointer variable have a string you want to like break it down. So if you have hello world, we can say char pointer string equal to hello world. So hello world now is exist or saved inside a pointer variable called string. So this is a pointer variable. We can say pointer variable to hold the string you want to break it down. And the third thing is char dlim or dlim, I think. Okay, what is the dlim? Okay, now if we go back to our example, we said that our function like come to this string and start to break it down and like give you hello in a place and the world in a place and from in a place and C in a place. Okay, right, that's what we said now. Okay, how, like we have a question now, how? Okay, before this we can say how our function no where or from where it should break down the string. Like, I mean, how my function recognize that I should break down the string from here and give you this result. And I scanned, so why is that my function didn't break down from here, or break down from here, or break down the string from here? Why it just come at the space and break it down? Because basically I give here, like, you can think about delim like a mark. You give your function a mark. You are saying to your function, whenever you see a space, you should break down the string. Okay, and of course your delim not supposed all the time to be space. It's depend on your string. Okay, so maybe if your string like do hard things, like they always say, so your dilim here will be this hyphen, not space. Why? Because your string now have hyphens as a separator between words. So your dilim is a separator or the mark you give your function to start to break down your string from here. Okay, so I can say you can imagine it like a mark. You give it to your function to start break down your string from there. Okay, so you can imagine your function really like a robot, and you have now a robot, and this robot just for breaking down something, and you are saying, or you given a command or information to the robot. If you found this mark, or you found this separator, you just should break down from here. Okay, so we now know what is the dilim, which is our separator or our mark to our function. So once our function found the separator in the string, it will start to break down the string. Okay, and the string, it's okay for this. It's the pointer variable refer to your string, and this is the returned value will be saved in this variable. Okay. Uh, okay. What else? Okay, the strtok function breaks a string into sequence of 0 or more non-empty tokens. On the first call to strtok, the string to be parsed should be specified in string. Okay. In each subsequent call that should parse the same string must be equal to null. Okay, I'll explain this now, but let's look at return value. The return value will set pointer to the token or null if there is no more tokens. Okay, so we can say return value on success, pointer to tokens, on error you can say null, or not error is we can say on okay, it's maybe it's error, or there is no more tokens. Okay, it's equal to null. And let's explain this line, or these two lines, or three lines. Okay. Okay. This line, to explain it, just we have to ask a question: how our robot or our function work? How it work? So if I have now do hard things, okay, I have my string. It's called do hard things, and I want to break it down. How my function work? We said that it's like a robot, so it's a come when you on the first call, when you call it. So we say token equals string talk, and you have a string here, and you have your dlim, and your dlim is a space. So on the first call, your function come here, and it will start to like scan your string. Okay, it has space here, so it will say, is D is a space? It will say no. Okay, is O is a space? No. Is a space is a space? Yes, it's a space. So it will not just break down and make a new line. it will put here null terminator. And why it put null terminator? Because we just said from a while that any string or array of string, it always end by null terminator. Why? Because it says to the computer or to the program, this is the end of this string, so you should like close the string now. Okay, so like now the function break down your string, and we know like do, it's 2 characters, so basically it's array of string. So at the end of array of string, or at the array, any array of string at its end, we should put null terminator. So because of that, it's here put null terminator. Okay, so as the first call, you will give it the string and the line or the len. Okay, and it will come here and scan, and once it's found the space or your dlim, whatever it is, it will put a mark for it. This mark is null terminator. And why null terminator? Because it's indication the end of this string now, and the result you will got, it's token token will equal to do. Okay, and then you will start to loop. We know that if we want to like apply line or 2 line of code more than 1 time, we have to make a loop. So now we want this line of code like 2 times. And if we have like a string do hard things from Alex or anything else, you will have to apply this code 1, 2, 3, 4 times. Okay, so now we will like go through a loop. Just I will not write the code now, but like imagine you are inside the loop and you are calling this function again, and let's check what's happened. Like in here, when we like read here, okay, this is the description. Yes, it said here string must be equal to null. Okay, so they mean here that it should like put null here instead of the string. Why? Let's just go back to string again, and if we put a string and didn't put any null, what will happen? You are saying, yeah, like basically and simply, you are saying to the function, go through do again, and every time go to two words or the first word, which is do, and break it down for me. So every time you are breaking down do function, do word, every time you are breaking down just do, no hard or no things or no next step. You are not moving forward, you just stay at your place, and you are still applying this code forever. Why forever? Because like okay, when I come to write the code, I will explain it. But for now, if you put a string here and you don't put null, you are staying at your place, which is do, and you are saying to the function to break down do only, or the first word only, without going forward or take a next step to the next word and break it down. Okay, but if you here said null, what does that mean? That is mean you are saying to your function, okay, you scanned this line before and you put a mark, and this mark is null terminator, and I need you to start scanning from after this mark. So if you put null and didn't put string, you are saying to the function, you scanned this string before and you put a mark, and your mark is null. So you should start from here. So your function, if you put it like this, your function will start to scan H and R and D, and H is not space, R is not a space, and D is not a space, but space is a space. So it will come here and put a null. And in your loop, when you are continuing your loop, you are saying again, because it's null, you are saying you scanned and you put null, and you have to go after this null, not from the beginning. So it will scan T, H, I, N, G, S. They are not a space, but then it find null. Why? Because it's the end of the string. So it will okay, on the second call, it will give you hard. On the third call, okay, we can say, just do this. it will put null here, and the last call, it will give you things, and then it will go out from the loop and end the loop. Okay, I will like explain it to on the code again, but for now, if like this is clear or not very clear or what. Mm, okay. Okay, I will explain it again while we are coding. Okay, so just let's try to make the steps, our steps. So string token function, we said that we have a pointer variable to hold the returned value from the function. So pointer variable, we can just say char token. And the second thing is your array of string. So char string, I will put array, and let's say do hard things. Do hard things. Let's make it all better. Okay, the third thing is just our dlem, which is our separator or our mark. Okay, so it's like this, will be the space because I have here space. And the fourth one is to call the function, and store the result. Uh, the second or the fifth is to go through while loop, يبقى to open a loop, and inside this loop you at first you will print the result. Why we should print before we call the function again? Because now we called the function for the first time, so our token now has some result from function, so we have to print the result at the first, then we should call the function again. Okay, so call the function again, and that's it, nothing else. So we can say vi strtok.c. What is library we have to include? String include stdio.h. Okay, int main, and we set we have to declare as first our variable which will store the result from string token, so it's token, and then our string of array of string, okay, string, which have do hard things. Okay, and then we have to declare our dlem, which equal space in our case, and then we said like we should call the function, like here we should call the function, so our token will equal string talk, the name of the function, and I will give it the string as the first parameter, and dline or dlem at the second parameter, and then I will go through a loop, and I will say whenever our token not equal to null, and that mean like it is not the end of our token, so keep looping. Okay, at the first we said we will print the result, so it will be like /s, oh sorry, %s and token, and then we will call it again, so our token will be equal string talk, and here null, and the lem, and I just will replace null with the string again to show you the result, and here return 0. Okay, so what I just need to say again here, token is not equal to null, which mean we are not at the end of the token, so just keep looping. Okay, and then we will print our result as a first, and then we will call the function again, and we just here, okay, do hard things. At the first it will come to do, like at the first call here, not here, it will come and break down do and put its not terminator, okay, or not terminate symbol. And on while loop, now it's not the end of our token. We still need, like, we still have some other places, okay. So it will come inside the loop and print the token, and then we replaced string by null, which mean I'm saying start from here and keep uh, like moving, so HRD, and then it will find the space. So here, it's find its dlim. So it's when it's find dlim, it will stop, and then it will go again, and it will check if it is the end of the token or the string. No, it's not the end. So it will print the result, which is like will be hard now, because it's like save it. We in this okay, in this line, it find hard and it break it down and save it here, and it go to check in while loop again. Are we null? No, we are not null yet. Okay, so it's go to print f and print the result, which is hard, and then it's called the function and store the result inside the function. At this call of the function, and now it has hard and not terminator. So it starts scanning from here, so it will find things, and at the end it find null. So it's store the result here, and then they go to check again at while loop. It is not is equal to null now. Yes, it's equal to null. So it will go out from the loop and return 0 as indication of success of the program, of the old program, okay. But what if I just put string here instead of null? Basically what will happen, just you have your function here. Okay, maybe just put it. Okay, it will, if you put string and you are keep looping, okay, it will come and scan do, and it will find a space or it's null. So it will, what is happen, it will like break down and make the do inside the token, and it will check if it's null or not, but it's not null now, it's still not null. So it will print do, and they go to do, just to do again, and it will break it down, and it will check for while loop. It's null. No, it's not equal to null. So it will print do and go back again. And when it go back again, it will scan for do only. So when it scan for do only, it will like break it down and put it inside the token, and you will check. So it's not equal to null. So it will print it like infinite loop without ending, because the condition, um, like for loop, it should be condition should be false to stop looping. So the condition will not be false, so it will not stop looping, and it will keep like printing do. Okay, so just let's print this and try the other thing. Dash o string strtok, strtok. Okay, here it's like do hard things, each one on the line, and it's like break down everything. Okay, like it's okay, but let's here try to like replace this by string, and let's try to compile. Okay, look, it's the infinite loop of do, because it's just like come on do and break it down every time, and because the condition doesn't turn to false, so it's just kept looping like infinite loop. Is it clear now or not? Okay. No answer. Okay. Okay, maybe we can move to the next one, and Next one is atty, I think. Okay. Okay. It's clear. Okay. Okay. Good. Is atty. Okay. Basically, is atty function. Test whether a file descriptor. Okay. Refer to terminal. Just let's copy this and then explain. Okay. Like basically is what is atty do? It's just like you give it fd. Fd, we said that like it's like id for file or for something you want to check. What do you want to check here? It checks if this id of that something of the file or of the program is connected to terminal or not. So it's like if you have a file and you want to check if this file connected to your terminal or not, just give fd of this file to this function, and like it will check if it connected to terminal or not, which mean you are interacting with the terminal. You can write and take inputs and give outputs and print errors or print messages on terminal or not. So what is do? Just check if this file or fd for file or for program or for anything is connected to terminal, so it can interact with the terminal or not, and return value on success, not on success, like if that file connected with terminal or that program connected with terminal, it return 1. So if it's connected, it return 1. If it is not, it's not connected, it return 0. Okay. I think that's all of this function. So just we maybe can take a small example. Just let's go to code. Like we can say if is atty, that's our function, and I want to check if I'm connected to the terminal or not. St d out file. No, I think. I think yes. Okay. Here I'm checking. This is standard output, so I'm checking if I am now connected with the terminal and I can print something on it or not. So I'm just using like printf connected, and if okay, and here else mean I'm not connected, so print if not connected. Here, like when you just make if statement without like put any condition, that's mean if this condition is true. So because of that, I'm saying if and didn't put anything after it, just because I'm saying if it's true, so said I'm connected. If it else, it's false. So if I'm not true or false, that means I'm not connected. Okay. GCC is atty dot c dash o is atty. Okay, I'm here. I'm connected to terminal, and I can just write on it and edit or print messages and anything. So it just in our code, even in sample shell, you can just put this condition, which is it is connected to standard output or not. but inside, like if condition, you should put your code, because if you are connected to terminal, you have to like execute some code, but if you're not connected, you have to execute other code. Okay, so this is like isatty. I think it's the most simple one. We can go for, yes, execute function, excessive one. Okay, execute the function or excessive function. It's execute like any program you give for it. Let's just copy this. Okay, like the first thing is our variable to store our result will be integer value, because like wait okay, yes, on error. Okay, on error it return -1. Okay, our variable here, we know that if execute function, if this function work and success, not failed, or there's no error, it will not return anything. It just will execute the program and overwrite the other code, which mean like we said before, if I have some code here and I called my function here, and I have another code here. So my function, what it will do, like it will execute this will be executed, and it will execute its commands, and it will overwritten or remove all this code. So any code after your the excessive function will be removed. Okay, so because of that, there is no result on success, but on failure it will take -1. So because of that, it's just the integer value, and we can like not declare any variable for return, like for result, just by checking at once. But it's okay, here it's a variable to store the result from the function. And the second thing it take, it's char path name, like if you write /bin/ls, so it's a path name for this command, so it takes the path name for the file which have the command. So we can say it's a pointer variable to store the name or the path name for the file. And argv, it's an array of arguments, which mean maybe we can say ls-l a or /temp or any flag you want. So this is array hold always the flag you want, or any other command you want to put. So it's an array of arguments. And like this is an array of an environmental variable, array of environmental variable. And if you don't have, or you don't want to use any environmental variable, you just put it null inside the function, or while you are calling the function. Return, we said on success it will return nothing, just will execute the command and will overwritten the other code. But on error it will return -1. Okay, so what if just we talk in our example, or in our code example of code, take excessive with fork and wait. It will be a good mix between all of them. Okay, so just let's go back. Okay, let's just summarize this. We said that it is like our store to save the return value or the result from function. We said on success it will return nothing, or it will return nothing, and on error it will return -1. For the path name, oh yes, we can just didn't declare any variable for this. Why? Because argv, which is your array of arguments, always start with the path name of the file. So when you declare your array of argument, you will say /bin/ls, and then you put your flag, which is -l, and then you can put any other flag you want, if a or anything else. Okay, so then the null, and this null it is instead of environment. Okay, sorry, this null for because it's array of string, and any array of string should end with null. So now instead of like declare and or define a variable for the path name, you just can give the function the first index of argv, because we know that in programming we start like we start counting from 0. So it's the index 0 or the position 0, it's index 1, and it's index 2, and this index 3. So on calling your function, the first parameter it should take the path name. So you just in calling function you can say like execve equal arg v of 0. And what it does that mean? That mean I'm just passing to the function the first index of the my array of argument, which is the path name. So instead of opening a new variable for the path name, I can just give it argv of 0, which is the first index, and the first index of argv will be the path name. Okay, so maybe we can just say we will use execve with fork and with wait function, both like 3 of them, and we just can like recap on fork and wait. We said that fork it's like split or separate the main process into 2 processes. One of them is called parent, and the second one is called child. And the parent, if you want to check if you are on the child process or on the parent process, if you are on the child process, it will give you like you should check by if PLD equal to 0. Why? Because 0 is like an indication you are on the child process now, and any other thing you are on the parent process. And we said when we made fork, the child process start to execute its program from the fork point, but the parent it start to execute its program from the line it's called. So always parent execute its program and finish or end its program and left the child, and this called orphan process or orphan status. So we don't want this to happen. So because of that we are using wait. And here basically I'm saying to the father or to the parent to wait his child while both of them execute their program together and both of them finish together. Okay, so let's try to like write the steps what we should do. The first, we said we will use execve and fork and wait. So we just will open a function, open a variable for execve. We can say result, and another variable. We said we can just use argv without the path name, or we can replace it by the path name. So we can say char asterisk argv of array, and I will give it value. And the third thing is bid for fork, bid/t bid, and I don't have to declare anything for wait. It's I just will give it null. Okay, and then we said we want to what is the flow of our code? We will just start our fork to make 2 processes. On the child process, I will call execve function to execute my command, and on the parent process I just will make him wait for the child. Okay, this is our flow. So what steps we need now? like we call fork system and then check for error because we have to handle every error, and then we check if we are on a child process, and if we on the child process we should like we call excessive function. Okay, so we call excessive function, and of course we will check for error, and then if there is no error with excessive function, it's now execute our program. So there is no error and it execute our program. So I will check if I am at the parent process. So if I am at the parent process, we said just it will make him wait for the child. So it's wait for the child, and we will end the program. Okay. So vi exe.c, and let's just collect our like libraries, and here we have to make yes fork. And we have also wait. System types, no, okay, the system wait only. H include stdio.h. Okay, this is for excessive and wait and fork. Okay, that's all. Int main, we said we'll open our variables for excessive, so it will take int result, and the path name we said the path name we said will replace it by argv, which is array of arguments. Okay, it's equal like open the array slash bin slash ls, and then like we said dash l, and here null, and this is because any array should end by null. And what else? Yes, for fork bid slash t bid, and the first thing we set the flow to make the fork, so bid equal fork, and let's check for error if bid equal to -1, and that means there is an error, so print error failed to fork. Okay, else if bid equal to 0, and that means I'm on child process. So if I am on child process, I have to call my excessive function, so result will equal to excessive. So we are calling excessive, we are giving it argv of 0, and that means the first index of argv, which is the path name, and that is what it needs basically, the path name, and then argv, and then null, and this null is replaced by environmental variables because we don't need to use environmental variables here. And we will check for error if result result, okay, equal to -1, print error, error, or can't execute. I can specify the error. Okay, and Okay, I will close else if, and I will say else. Else here mean I'm on the parent process, and we said I will just make the parent to wait for the child. So it's wait and print if done execution return 0 at success of the function gcc we call it, yes, okay, dash o exe. Okay, it executes the program and then done with execution or done execution. Okay, so that's mean. And like if we just try to make it again, you notice that everything come together. So the result of the child and the parent come together, both of them. Why? Because parent wait until child finish, and both of them end of the program together. Okay, is it clear, or there is something or question? Okay, okay. Um, mm, I think no one. Okay, okay. Okay. Okay, let's go to malloc. Okay, but before malloc, I just look. I will try to say a story, simple story, and the story like just to explain or to make you imagine what malloc do. So yeah, like don't laugh at me. Okay, like imagine that you want to buy a car, or you bought a car and you want to have a garage or garage. I don't know how it's called. Wait. Um, garage. Okay, it's garage. Yes, it's a garage, which the place which you store your car. So now you bought a car and you want to buy a garage or garage to store your car inside this garage to store it and save it and protect your car. So you basically go to someone, and that someone you said to him, I want to have a garage to store my car or to protect my car inside this space. So basically, the first question this someone will ask you, it will say how much space you want this garage, or like how much space is the space you need. So you will just try to calculate the size of your car, and depend on the size of your car, you will give him an information how much space you need for your garage. Okay, so now let's imagine that this after 2 days, this man come to you and they say, okay, I found a suitable one for you, and it sends you the addresses of the garage. Okay, so after some days, it return back with the addresses of garage. Okay, uh, and maybe in another way, or like in another scenario, maybe it's come back and say I didn't found anything. So in both cases, the first one, it gives you the addresses, and the second one, it gives you like nothing. Um, so I'm saying that to imagine malloc is that someone, just that someone which you go to him and ask him to find you a space or a garage to, or any empty space to protect your car inside it. So this is malloc, and your car, it's like the size of your car, it's the parameter malloc needs, because this is the information that the man asks you how much space you need for your car. So the only parameter malloc need is the size of space you need to open. Okay, and the garage, it's the memory you have in your computer. The memory, it's your garage in this story, which is like how much space you need to store your value or your data inside it. So you can imagine malloc as that man who you asked him to find you a space, and the parameter it takes the only information that man will ask you to find how much space you need, and this space is memory, or like the spaces you put your value, so you put your car inside it, it's a memory. Okay, and I said after 2 days that man returned back by the addresses of the garage. So the returned value from malloc, it's the pointer variable to the addresses of the space. So it will return you the addresses of the garage or addresses of the space which it found for you, or he will come back and say I found nothing, so it will return nothing. Okay, so okay, this is like a story just to make everything clear. So we have here malloc. Just we will take malloc here and free also. So allocate and free dynamic memory, and if we want to use, okay, maybe if we want to use this function, we will have our library, and we said the first thing is the variable we need. We said that we have a variable. This variable will hold pointer variable to the addresses, or will hold the addresses of the garage or of the space. And whenever we want to put an addresses inside the variable, it will be a pointer variable. So a pointer variable to hold the result or the addresses, yes, of memory. And like the first and only parameter it takes, it is the size of bytes or bytes, okay, or how much space you need in memory. Okay, um, and we said that it just open for you a place in memory, and we said return value is on success to return addresses of the allocated memory, so addresses for the garage. And on error it return null, nothing. Let's check it out on error. Yes, on error this is return null, yes. Okay, and the free function, it's just like free, like in the story, if you like sell your car, or you just will sell your car and you don't need your car anymore, so that's mean you will not need for the garage anymore, so you have to free the garage, so you have to free it to sell it. So free, just to free the spaces you opened from the beginning. So free, just free like the space or the memory. We can come here and say yes, that's it. Okay, free, okay, this is malloc. Oh, it is the same. Okay, okay, free take the like the pointer by pointer, and that's mean the returned value from malloc. So you can just come here. So like if you open here like char buffer, and this buffer like equal malloc, and you call the function and set up everything. So you will take this variable here and put it inside free. That means free, the only parameter free takes, it's just the variable holds the result from malloc. Okay, so if we just want to like use both of them, we can say steps. The first thing we should declare char buffer, which like holding the result come from malloc function, and size t for size, and it will hold how much spaces you need inside your garage. Okay, so in our my example, I will put I will make the user just put the size himself, not me. So maybe you can prompt to the user to enter integer to allocate number 4. After that, I just will take and save the value. And number 5, I will call the function call malloc and store the result in buffer, and check for error, of course, check for errors. And okay, maybe I can print not print, I just will put value inside these spaces and then print them. So I if like maybe we can put 10 or 11. So we will make for loop, or we will make loop, and basically this loop to assign value inside the spaces we opened, because the space is empty now without any cars, so without any value. I just will make for loop to put value inside these spaces, and we'll make for loop or other loop to print the value, and then we will free the memory. I think that's all. So we can come here and vi malloc, let's see, standard lib and include stdio.h. It's the same too. Okay, so I just will start. Okay, int main int I, this I for loop, for the loop, and I will start then char buffer, and the size t size. Okay, and then we said that I will prompt for the user to enter a number. This number will be like how, okay, like, okay, wait. Like here, for example, I prompt the user to enter a number and he entered 5. What does that mean? That means I will open 5 spaces in memory. So I will open room 1, and you can say it room. So room 1, room 2, room 3, room 4, room 5. Okay, so this is room 1, and this room 2, and this is 3 and 4 and 5. Okay, so now our, like, I opened our 5 rooms inside the memory, but basically this rooms is empty. Because of that, I just will make for loop to loop over each room and put value for each one, and I will make another loop. So the first for loop, the first one will put here a variable value. So maybe here 1, here 2, here 3, and here 4, and here 5. Okay, and the second for loop just will loop to print all this value out on the screen again. Okay, I now will prompt the user like printf to enter a number or number of room he wants us to open. So enter the number, we can say the number to allocate. I think that's all. Okay, and I will close this and I will use scanf y to get the number from the user. So I will say %d and ampersand to size to save this number to use it after or to use it. So we have here our buffer. We will open it and we will use malloc, but after malloc we will just say int asterisk. We say here malloc, and we will give malloc the size, which is the number of room it should open, and this is multiplied by size of integer, and that's y. Okay, that's all. Like here malloc it takes size, okay, and this size is the number of room to open. Like if we said here, if the user enter 5, it will open 5 room. It enter 2, it will open 2 room. This is the meaning of the size. Okay, what is the meaning size of int? We know that every type in C has a value. So char has type 1. So if we like set 5 multiply 1, it's like the entire space of the room is 5, but int I think it's 4. So if we multiply, it will be I think 20. So it's the entire size of the room, it will be 20. Okay, so we will check for error. So if buffer equal to null, we said if he can't find a garage for you, it will come with nothing, so it will with null. So print if can't allocate memory. Okay, before this you can say okay, and else that's mean it allocated memory in allocated space in memory. We will open for loop. We said we will open for loop for assign value on each room we opened. Okay, so we here I equals 0, and I it's less than size, which mean less than the number of room we opened, and I plus plus. So keep looping for every room buffer of I. So for like I plus 1, like for every room I want the value for every room would be I plus 1. So I is the first equals 0. So the first room, like here, if we just like remove all of this, like if let's say 3 rooms, so this is room 1, room 2, room 3. Our line of code which you say buff of I equal I plus 1, here buff of I equal to 0. So the first one is 0, and the second one is 1, and the third one is 2. So buff of I now here is 0. Okay, 0, we in the line we said I plus 1. So I is 0. So plus 1, which mean here the value will be 1. Here the buff of I is equal to 1 plus 1. So that's mean here it will be, okay, it will be 2. Yes, it will be 2. Here buff of I will be 2. Here it's 2. So here the value of the room, it will be 3. Okay, so that is the meaning of this line. And what else? We said that we make for loop for assign value for each room, and we will make another loop to print the old value inside this room. But okay, so we just can say print if numbers. This is before the second loop, and then we will start our loop. So for I equal to 0 and I is less than size again, and I plus plus, the same loop but just for print f slash d, and we have here buffer of I. Okay, and we have to free, but not here. I think we should close the second brackets, and we have to free the buffer and return 0, and I think that's all. Okay. Okay. We can just make it integer value. Okay. Let's check. Mm. Okay, you are right. You are right. Yes, yes. Okay, you are a good debugger. Okay, we can say 5. So the number is 1, 2, 3, 4, 5. Just we can make a new line to make it clear. Print if a new line. It's before free, right? I think yes. So okay, let's say 10. So numbers is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is basically about malloc and free. So is it clear, or I shouldn't ask this question? Okay. Um, buffer y argv. I thought the first parameter holds a buffer y argv. Okay. Um, okay, but I didn't read the article yet, so maybe you should guide me. Okay. gc dash g. The command is dash g or what? Okay, can you write the command on chat to compile? In what situation we need to loop to free memory allocation? Mm, I don't know, but wait. Yes, I get you. But Okay, use maybe because we give free function just one pointer, so we are giving it just one array, not all of them. So maybe that. Okay, maybe really. Okay, let's check ChatGPT. Are not typically used directly for freeing memory. Are usually handled by specific functions or mechanisms by the programming language or library. However, loops can indirectly play a role in freeing memory. Okay, I'm sorry. Under certain conditions, here are some few scenarios. Dynamic memory allocation with a loop. Okay, he is saying that as a first condition, if you allocate memory in a loop, so you should free it in a loop too, in the same loop. Okay, so if you use the malloc inside the loop, so you should use free inside the same loop at the end of this loop. Memory deallocation in a loop, in some cases, collection of dynamically allocated memory blocks that need to be freed. You can iterate over the allocation using loop and free each memory blocked. Okay. So in case of data structure or complicated data structure, and in case of you use the malloc inside loop, so you should use free inside the same loop at the end of this loop. I think that's all from ChatGPT, not me. Okay. So you just will write this, and there's the name of executable file, not the one I compiled, right? Okay. Um, it's called malloc. A memory check, a memory error detector. I think it's 10. Yes, I pushed enter. Yes. No leaks. No leaks are possible. Wow. Okay. Okay, I learned something new from you now. Of course. Mm. Okay. Yes, yes, I get you. Each array of character. Yes, yes, I get you. I get you. Okay, and last, we shouldn't forget this question. I saw the first parameter hold a buffer. Why argv? Okay, it's okay. Vi exe.c. Okay, you are here saying in excessive function we should use buffer or path name to the program, not argv of 0, right? Okay, excessive. Okay, we said here in our argv it's an array of argument, and this array at the first index of it holds the name of the program or the path name for the program or the file, and the second position it's a flags, any flags you want to use. So I said you can just open a buffer or the path name holding the name of the program and use it inside the excessive function. But I said also you can, instead of open or declare or define a variable for the path name, because our argv have the option and have the name of the file or the bus name of the file at the first index, we just can pass the first index of the argv inside our function and it will work. But if you just did that and you here said char path name equal to slash bin slash ls, and we close it here and you put it here, and instead of argv of 0 it will work too. So gcc ex e.c dash o dash o not 0 dash o exe. No input files or directory. Why? Is the path name I think it's clear. It's okay. Wait, I'm not sure what is. Okay. It's compiled by C. It's worked too. So there is no errors here or at the first time, because your path name will hold the path for the file and the argv index 0 holding the path for the file. So I just, instead of declaring a variable holding a value, I have this value here, I just used instead of the path name I used argv of 0, which mean, what is the meaning of argv of 0? Like we can argv of 0 if we are counting like it's array, so the first index, this is all is the first index, and what? Okay, I solved this problem, I know. Wait, I repaired it, thank you. Okay, so I just want to say, in both cases, if you declared a variable to store the path name and pass it for the excessive function, it will work. But if you use the argv of index 0, because the index 0 has the same path name, and give it to the function, it will work too because it's the same. I hope it's clear for who was asking about that. Uh, hmm, hmm, okay, good. So maybe we just move to the next. We have here get current working directory. Okay, okay. So here at the first, it's like pointer variable holding the returned value from the function. What does the function do? It just like return or giving you the full absolute path to your current working directory. Okay, the full absolute path. So because of that, we need here pointer variable, which mean like a string or like array of string will hold the full path or full absolute, because there is another path called the relative, the full absolute path of your current working directory. So it's a pointer variable to hold the absolute path for the current working directory, and char buff and the char size, like it's a temporary store. Like when this function read the absolute working directory, it's like write it here. So it's like a store when the function like read or get the absolute name or path for the dir, it just save it here temporary, save it here, and the size, it's like the size or length or number of bytes, or number like number of bytes of character it read to return back the full absolute path name for your current directory. And we can check return value. On success, this function return a pointer to a string containing the path name of the current working directory in the same value of buffer. On failure, this function return null. So on error, on success, return pointer variable to string has the path name, and on error it return null. Okay, so what do we need? The first thing is just to like open your result variable, or variable hold the result. So it's type char asterisk, and we can say result. And second thing is to open your buffer. So char I will make it buffer, and I will put some size here. And the third thing is to open the size, which holds the size of the buffer. And what else? I just will call the function, call the function, and check for error, of course. And then I will print like the name or the path, absolute path name of our current working directory. So we can just say print the path to our current working directory. Okay, so let's just try to take the code or write it. current working directory.c. اوكي جي مش مشكلة. int main, and we can say char asterisk result, and char buffer. Here I just will put like size for my buffer, or like maximum number of character it can read. So I just will put 100, not to give me memory leak or memory error. And here size t equal to size, and here size I will just like have size will equal to size of my buffer. I just here like specified the number of character I can read from, just like you can say I allocated memory but manually without using malloc. Okay, and the size I bring the size by size of buffer. Okay, so then I will call the function. So I will say result, okay, result equal get current working directory, and it takes the buffer and the size as two parameters, and we will check for error. So if result, okay, I felt there's something wrong. Okay, result, if result equal to null, that means there is an error. So I'm checking for error, print error, error. And if there is no error, so everything is okay, and I get the path name or the full path for my current working directory, I just will print it. So current current working directory is, and I just will put the path in buffer, return 0. I think that's all, and we can gcc cwg dash o cwd current working directory. Okay, current working directory is /root /symbol. So I just get the full path name or full and absolute path for my current working directory. Okay. I think the last one is get PID, and it's so simple. So it's like get PID. It is for getting the process ID or process identification. We need to these two libraries. Okay, and it take nothing here. Void, it's mean it take no parameter, just call it, and you should have a variable. This variable like hold the returned value from the function. And I think just let's go to, okay, there is no returned value from the function because it just will print or get you the, okay, return the process ID of the calling process. Okay, just it. Okay, so just if you want to use it, just you have PID, which means variable from type PID to hold the result from the function. So if we just get PID and we include these two libraries, and we have to include slash include stdio.h int name PID slash t PID, and just PID equal to get, it's a get PID function, and like printf my PID is, and just slash s slash s not slash d percent t and new line, and here PID return 0, and end of the program gcc get PID dash o get PID.c get PID. Okay, okay, it's my PID, and it's like 2491. So just this function to use it, it's so simple. Just to call it and like restore the variable, the value or the result in a variable, and just you can like check in this value or do like anything you want. But just here I'm trying to simplify how to use it, so I just print it. So I think that's all today. We can stop this record.